Somewhere beneath the red dust of Mars, there's a layer of the planet that nobody has ever seen with their own eyes. Not a rover, not an orbiter, not a single human being in the history of our species. And for years, the only way to even guess what was down there was to send a radio wave into the ground and listen to the echo. Now that job has been handed to something else, something that doesn't get tired, doesn't get bored, and doesn't miss the patterns buried inside decades of noise. And when it started reading the data again, it didn't confirm what scientists expected. Read that again. It didn't confirm what they expected. For almost 2 decades, Mars has been sending back signals from beneath its surface, and for almost 2 decades, humans have been doing their best to interpret them by hand. That's the part most people don't understand when they hear about Mars discoveries. The rover doesn't just drive around snapping photos. Underneath Perseverance, there's an instrument called RIMFAX, a ground-penetrating radar built specifically to send pulses into the Martian crust and catch what bounces back. Ground-penetrating radar observations of subsurface structures in the floor of Jezero crater are potentially compatible with a history of long-lived igneous activity and a history of multiple aqueous episodes on Mars. That single sentence sounds calm. It is not calm. It means that 30 feet below the wheels of a rover currently driving across Mars, there are ancient structures that could be frozen lava or could be the remains of water that once flowed there. And for years, scientists could not agree on which one it was. Here is where it gets uncomfortable. Perseverance's own surface observations from its cameras and instruments seem to favor an igneous origin for these buried layers, rock formed by molten activity. But the radar was telling a different story. The high-resolution radar signature from a formation called the Artubi Ridge closely resembled the kind of pattern typically produced by sedimentary deposits, the layered rock that forms when water carries and settles material over time. 2 completely different tools pointed at the same patch of ground, whispering 2 different explanations. Fire or water, and nobody could prove which one was lying. This is the part most casual space coverage skips over, because it isn't a clean headline, it's a contradiction. And contradictions are exactly the kind of thing that gets buried under a press release that says exciting new findings and moves on. But this contradiction matters more than almost anything else happening on that planet right now, because the answer changes everything we think we know about whether Mars was ever alive. Think about what that actually means. If those layers are sedimentary, it means water didn't just visit Jezero crater once and evaporate. It means water sat there long enough, in a stable enough environment, to slowly stack mineral layers on top of each other, the way a lake bed does on Earth. That is not a splash. That is a system, a working, cycling, possibly habitable system, sealed and preserved underground for billions of years, untouched by the radiation and freezing vacuum that sterilizes everything on the surface. And it has been sitting there the entire time, waiting for someone, or something, to finally read it correctly. But here's where it gets worse. Jezero crater isn't even the most dramatic radar mystery on Mars. Go back further, to 2018, when a completely different radar instrument on a completely different spacecraft picked up something that made headlines around the world. Scientists, using the Mars Advanced Radar for Subsurface and Ionosphere Sounding Instrument aboard the European Space Agency's Mars Express Orbiter, detected an unusually bright, highly reflective signal buried beneath the ice sheet at the Martian South Pole. Liquid water reflects radar almost like a mirror. Rock and dry ice barely reflected at all, and this signal was bright, startlingly bright. The 2018 discovery of what appeared to be an underground lake set off a flurry of scientific activity, because water is one of the most fundamental ingredients linked to the possibility of life anywhere in the solar system. For a moment, the entire planetary science community believed they had found something that changes the human story. Not just evidence that water once existed on Mars, every serious researcher already accepted that, but evidence that liquid water might still exist there today, sealed under kilometers of ice in the dark, at temperatures and pressures where it theoretically shouldn't be able to survive as a liquid at all. If true, it meant Mars still had a heartbeat, a hidden reservoir, maybe even a hidden habitat. And then the story took a turn nobody wanted. Years later, a more advanced radar technique revisited the exact same spot. Researchers analyzing data from an enhanced radar method concluded that the area suspected of being an underground lake is more likely to be nothing more than a layer of rock and dust. Not water, not a hidden ocean, a cold, dry geological illusion that had fooled some of the most sophisticated instruments humanity has ever sent to another planet. Whatever is producing that strong radar reflection at the South Pole, according to the newer analysis, it most likely isn't liquid water after all. This is not chaos. This is Mars, doing what it has done to us over and over again for 50 years, offering just enough signal to make us believe, and then pulling it back before we can be sure. Every time humanity thinks it has finally caught the planet's secret, the ground shifts. And that reversal, that quiet public retraction, is exactly the moment where most people stop paying attention. The headlines about a Martian lake spread across the planet in 2018. The headlines admitting it probably wasn't a lake, barely made a ripple. But something else was happening quietly underneath that entire debate, something that changes the stakes of everything that comes next in this story. Humans were no longer the only ones reading these signals. According to researchers working with a new class of subsurface interpretation systems, artificial intelligence has now been applied directly to this exact kind of Martian radar data. And it isn't just confirming old conclusions. A promptable AI foundation model built for subsurface interpretation has demonstrated the ability to generalize to entirely new types of data it was never specifically trained on, including radargrams collected by the Mars Reconnaissance Orbiter's shared instrument, data showing the three-dimensional internal structure of Mars' polar layered deposits. Read that again. A system trained largely on Earth's subsurface geology, oil, seismic faults, underground formations here on our own planet, was pointed at raw Martian radar data it had never encountered before. And it didn't just process it, it understood it. The same model has already shown a strong capability for detecting and mapping multiple types of geological faults in complex seismic data on Earth, a level of structural interpretation that has remained genuinely difficult even for other existing AI approaches. Now take that capability and point it at a planet where humans have spent 20 years squinting at faint, noisy radar echoes, arguing in academic papers about whether a bright pixel means water or rock. What happens when a machine that never gets fatigued, never gets attached to a hypothesis, and never needs funding to keep believing in its own theory, starts reading through that entire 20-year archive in a fraction of the time? This is where most explainer videos would stop, satisfied with AI helps scientists. But that undersells what's actually shifting, because the value of this technology isn't in helping humans do the same job faster. It's in the fact that it can see patterns nobody was looking for in the first place. Human scientists search for what they expect to find. They come to the data with a hypothesis: water or rock, igneous or sedimentary, lake or illusion. An AI system trained across enormous unrelated volumes of subsurface data doesn't necessarily carry that bias. It doesn't know it's supposed to be looking for a lake. It just looks for structure. And structure that humans didn't think to search for is exactly the kind of structure that changes a scientific consensus overnight. Think about what that means for every previous Mars radar dataset currently sitting in an archive somewhere at JPL, at the Italian Space Agency, at the labs in China analyzing their own rover's data. None of that historical information has to be thrown away, and none of it requires a new mission to revisit. It can simply be reread. Every radar pass Marsis has ever taken. Every trace Rimfax has recorded under Perseverance's wheels. Every shared orbit sweeping over the poles. All of it can be run back through a system that might catch what human eyes, however brilliant, were never built to catch in raw electromagnetic noise. And that is precisely why the deeper implications of this story are less about one crater and more about a race that almost nobody outside the space community is talking about. Because Mars radar isn't only an American story. China's Zhurong rover has used its own ground-penetrating radar to reveal layered subsurface structures in the Utopia Basin region of Mars, an entirely separate landing site, an entirely separate national program, gathering its own independent data set of what lies beneath a different part of the planet. That means there are now at least 3 major competing streams of subsurface radar data being collected by 3 different space powers: the United States, the European Space Agency, and China, each one probing the same fundamental question from a different angle of the planet. And whichever nation's scientists, whichever nation's AI systems correctly decode what's underneath first, doesn't just win a research paper, they win the map. Think about what that actually means in practical terms, because this is where the story stops being abstract and starts being strategic. If a specific region of Mars is confirmed to hold accessible subsurface water ice, or a stable buried aquifer, or mineral-rich sedimentary basins, that location becomes the single most valuable piece of real estate on another planet. OUS water means fuel because it can be split into hydrogen and oxygen for rocket propellant. Water means life support for a human crew that cannot survive on shipped-in supplies alone for a multi-year mission. Water, if it's ever found to still be liquid and stable, means the single most important astrobiology target humanity has ever identified. A place where searching for microbial life would no longer be a long-shot experiment. It would be the primary objective of an entire generation of missions. And this is where everything changes, because the question stops being, is there water on Mars? Every serious space agency already accepts that Mars once had lakes, rivers, and possibly oceans billions of years ago, before the planet lost its magnetic field and most of its atmosphere boiled away into space. The real question, the one that current radar analysis and the AI systems reinterpreting it are actually chasing, is far sharper. Is there anything left down there now, sealed away and protected from that catastrophe? And can we find it before someone else does? According to informed voices within the planetary science and AI research community, this is precisely why the fusion of ground-penetrating radar and machine learning interpretation has quietly become one of the most closely watched developments in Mars exploration, even though it rarely makes front-page headlines the way a rover selfie does. Researchers have specifically been investigating the capabilities of deep learning models to process and interpret multi-offset ground-penetrating radar data for lunar and Martian environments, building systems explicitly designed to strip away noise and reveal structure buried in signals that would otherwise be dismissed as static. What most people are not seeing is that this isn't a side project. It's a foundational shift in how an entire planet gets read. And it isn't limited to interpreting old data sitting in an archive. It's already changing how machines operate on Mars in real time. NASA's Perseverance rover has completed its first AI-planned drive on Mars using a form of generative AI known as vision language models to examine existing mission data and independently identify safe waypoints across difficult Martian terrain, work carried out in collaboration with Anthropic using its Claude AI models. Think about the timing of that. The same period in which subsurface radar data is being reanalyzed by advanced AI is the same period in which the rover's own physical movement across the surface is being planned by AI as well. Mars sits an average of roughly 140 million miles from Earth, a distance that creates communication delays long enough to make real-time human control of the rover physically impossible. That delay has always been the hard limit of human-led Mars exploration. A round-trip radio signal can take the better part of an hour. Every command has to be planned in advance, sent, and then waited on, blind, hoping the rover doesn't roll into a ditch nobody could see from orbit. But an AI system embedded in the rover itself doesn't wait for permission from Earth. It reads the terrain, reads the data, and decides. And if that same category of system is capable of independently reading subsurface radar signatures with the same autonomy, the entire tempo of Mars exploration changes. Discoveries that once took years of academic back and forth, papers published, conferences held, peer review completed, arguments settled, could begin to surface in a fraction of that time. Not because humans got smarter, because the bottleneck was never human intelligence, it was human bandwidth. This is the part that should make anyone pause. For the entire history of space exploration, discovery has moved at the speed of human institutions. Grant approval, mission planning, data review boards, publication cycles. That pace has been slow, deliberate, and cautious by design, because being wrong about something as significant as water or life on another planet carries enormous consequences, scientific and political. Now, for the first time, there's a class of tool that can process the raw signal faster than any of those institutions can convene a meeting about it. The science hasn't changed, the evidence hasn't changed, but the speed at which hidden patterns can surface has changed completely, and that shift is happening right now, quietly, inside datasets that are already sitting on hard drives at multiple space agencies around the world. So think about what happens next. If an AI system rereading archived SHARED, MARSICE, or RIMFAX data identifies a subsurface signature strong enough to reopen the water debate, that finding doesn't stay contained to a research paper. It becomes leverage. It becomes the justification for the next multi-billion-dollar mission proposal. It becomes a talking point in the increasingly public competition between American, European, and Chinese Mars programs about who is actually leading humanity's return to the red planet. Whoever can point to their own independently verified subsurface map and say with confidence, "We know what's down there and you don't," controls the narrative of the next decade of Mars exploration, and very possibly the choice of where the first human boots ever touched that ground. And this is where the uncertainty becomes almost uncomfortable to sit with. Because for all the confidence radar science tries to project, the honest history of Mars subsurface research is a history of reversal. The 2018 lake became rock and dust. The Jezero crater layers still cannot be conclusively called fire or water. Every discovery in this field has so far come with an asterisk, which means the AI systems now reinterpreting decades of this data aren't stepping into a settled field and simply speeding up the confirmation of known facts. They're stepping into a field littered with retracted headlines, contested interpretations, and instruments that have fooled brilliant scientists before. If a machine trained to find patterns starts finding new ones in that same messy archive, the question that should keep researchers up at night isn't just, what did it find? It's, how do we know this time it isn't fooling us the same way the ice did in 2018? Because here is the deeper, less comfortable truth sitting underneath this entire story. Radar doesn't lie, but it also doesn't explain itself. It returns a signal, a pattern of reflection and absorption, and every single interpretation of what the pattern means, water, rock, ice, brine, ancient lakebed, cooling lava, has always been a human guess laid on top of raw physics. An AI system doesn't remove that layer of interpretation. It just does the guessing at a scale and speed no human team ever could, drawing on more comparative data than any individual scientist could hold in their head at once. That makes it powerful. It does not automatically make it right. Think about what that means for the next major announcement out of Mars, whenever it comes. Somewhere in an archive right now, there's very likely a radar trace that an AI system has already flagged as anomalous, a signature that doesn't cleanly match rock, doesn't cleanly match ice, and doesn't cleanly match anything in its training data. Nobody outside a small circle of researchers may even know it exists yet. It could be nothing, a processing artifact, a trick of geometry the way the 2018 signal turned out to be, or it could be sitting at the edge of the most significant subsurface discovery Mars has ever offered. The kind of signal that, if confirmed, forces every space agency on Earth to redraw its priority list overnight. What most people are not seeing in all the casual coverage of AI helping rovers drive themselves and helping scientists read old data faster is that the real story was never really about convenience. It was about who gets to ask Mars the right questions first, and who is left reacting to an announcement someone else already made. Every layer of rock beneath Jezero crater, every bright reflector under the south polar ice, every unexplained echo in the Utopia basin is a closed door that has been standing there for 4.5 billion years. Humans have been knocking politely, with instruments built to listen for one very specific kind of answer. Now something is knocking differently, faster, and without the same assumptions about what it expects to hear back. So the questions that remain aren't small ones, and none of them have a confirmed answer yet. Is there a version of Mars's subsurface map, quietly compiled by an AI system somewhere between JPL, Rome, and Beijing, that already shows something the public hasn't been told about? Is the still unresolved contradiction at Jezero crater, fire or water, about to be settled not by a future rover mission, but by a machine finishing the analysis of data that's already sitting in an archive today? And when that answer finally comes, whichever direction it points, will it be treated as a scientific milestone belonging to all of humanity, or as a strategic asset belonging to whichever nation's system found it first? Mars has kept its deepest layer of secrets sealed for billions of years. The instruments listening at its surface have only just started to disagree with each other loudly enough for the rest of us to notice. What happens when something finally listens back correctly is still, right now, completely unwritten.